Welcome back to my channel, and today we're going to talk about something that's really cool, which is the ability to create Spark tables on top of Azure SQL Database tables. And in fact, it should work just as well on any sort of variation of Azure SQL PaaS solutions, including MySQL and Postgres. Though I haven't tested those PaaS services, I will demonstrate how to do this on Azure SQL Database. So this is going from a Databricks notebook, but again, it should also apply to Spark in general. So either way you're using Spark should apply. And by the way, today's mug is Azure. I got my own Azure mug. I got a whole bunch of different Microsoft Azure mugs and things now, because you can never have enough weird nerd mugs. Let's jump in. I do want to mention a plug for my book, which took me almost a year to write, which is called Master Azure Databricks Step by Step. Now, Databricks is really a wrapper around Apache Spark. So probably about 85 to 90% of this book applies just to general Apache Spark, especially when you talk about using languages like Python with PySpark, or R with Sparkly R or Spark R. Applies the same, and a lot of the other concepts. So if you just want the information there, it's got some really good coverage, but it is a comprehensive Azure Databricks resource. I wanted a book, the kind I like really, is one that takes you step by step, but also gives you a lot of depth, and that I can go back and refer to how to do specific things. Now, this book is designed to take you from beginner to expert. When I was at Microsoft and did a lot of sales and talking to customers around Azure Databricks, I found people just had a really hard time getting up and running with it because there's so many different sources of materials, very few good references with actual code examples. So I wanted to write a book like that. And it's very step-by-step. It uses an AdventureWorks use case. And I know AdventureWorks is used a lot for things, but it provides a good data set that you can use that's safe. Nobody owns it. There's no proprietary risk. But I take it as you have a business problem management's asked you to solve. And I take you through exploratory data analysis and doing things and creating your clusters in Spark, using Databricks notebooks, all the way through to training predictive models using the Azure Machine Learning Service integrating with Databricks. So everything from soup to nuts is in there. It's available on Amazon, so go get it now. It's currently only in the ebook format. If I see more and more demand, I can get the print version, but it's a pretty hefty book. It's over 600 pages, so it's not a lightweight. It goes into a lot of detail. So you might find it a little heavy to read anyway as a printed book. So let's get into this topic, which I think is really interesting, which is Spark table riding on top of an Azure SQL table. So imagine we have an Azure SQL database. And we've got a bunch of tables in there. You know, it's something our company has. This is a very popular service. And we'd like to be able to query and use them from Apache Spark. Now, we know we can use typical JDBC interfaces and query, but it gets to be a bit tedious after a while. If we need to keep querying the same tables, it'd be kind of nice if we could just have a local table and treat it just like good old Spark SQL, but behind the scenes it will do the communication necessary to get the data and manipulate it back on our backend database. So imagine we have this Spark table. We call it table locally My Sales, but My Sales is connecting to our Azure SQL database using JDBC, and it could be like AdventureWorks sales, like sales dot whatever table, and it's going to query and do things against that. Now that has a lot of value to us because once we create the table, it's local, it's persistent, and we don't have to worry about creating it again. We don't have to worry about any of these, different things. So it's a pretty cool idea. So let me jump in here for a minute. What I want to show you is I'm now in my Microsoft Azure portal, and I've created this database, AW. It's under a server name I created, which is Azure SQL, not surprising, YouTube for this demo. And one of the things I wanted to show you is that I connected into this query editor. Now the query editor is in preview. I hope Microsoft keeps it. It's very handy to be able to query data in the service without having to go external. But it's got the query editor, and you can see these are the tables we have. So ones that we're really going to focus on is this one, which is the sales address table. And if I click on this little button, it'll let me do a quick query of it. So we've got addresses here, and we have another one, which is the sales LT customer. Now what I'm using that's kind of handy is when you create an Azure SQL database, it gives you the option of having a sample database created, and it just gives you a handful of the AdventureWorks tables. So it's a good way just to have something to play around, quick and dirty. It's great for demos. That's a great thing that Microsoft does. I really like. They give you a lot of ways to show off and do demonstrations like this. So that's what you've got here. Now I want to show you this because we're going to have to know, how do we connect to this? Well, we need the server name. We'll see this in a minute. And we, of course, need to know the database is just AW for AdventureWorks. So we know two of the key things. So let's jump over to the star of the show, which is a Databricks notebook. I'm going to be demonstrating this. I've got little notes at the top. I will put a link to this, so you'll see this in the description where you can get the notebook. It's actually two notebooks, which you'll see in a minute, and you can just play with it yourself. So this is where we got the server name over here. It's in the overview blade of where we created our Azure SQL database. The name of the database. Now the standard port, if we don't change it for communicating to Azure SQL Database, is 1433. You do have to make sure you leave like public access open and things so that it can get to it. So tweak your security that fits your requirements. I'm doing this for demo purposes. Don't do this at home if you're worried about securing it. Not too worried about Azure's AdventureWorks data. So, but I wanted to just demonstrate what you got here. And in the end, we're creating a URL which is going to be used to connect to the server. So I'm going to run this cell by pressing Control Enter. And we can see we have our string. Now, if you're not familiar with Python, by using these 012 placeholders, we can do the format method and just place these properties into it. So that's how we get this formatted. We can use it. I don't want you to see my user ID and password in. You shouldn't expose those either. Now, the right way to store those is using Azure Key Vault. And there's a great feature with Databricks to integrate with Azure Key Vault called Databricks Secrets. I have a whole riveting video. I will post the link to that at the end, so you can go to that as well. Subscribe to my channel so you can get all this great content. But in there you'll see how to really securely set up passwords and things so that nobody can get at them and securely. I'm doing a sort of workaround so I don't have to show you what my password is. I'm using the %run macro or magic, and I'm running a notebook which is in the same folder, which is called set credentials, and you'll get this with the zip folder I'll create on GitHub. All right, now I do want to, so that's going to get the user ID and password set up. I do want to mention, notice that when we plug in certain parameters within this connection, we have to include quotes in the string value, which sometimes can be a little hairy depending on your language, but fortunately, Python allows you to use either single quotes or double quotes for any string values. Whichever one you use, you can embed the alternate other, so you can use single quotes on the outside, double quotes on the inside, and it will retain the double quotes as part of the string. And that's key because we need to do that. Just to kind of open up this markdown cell to show you what I mean, internally the way the password or the ID was set is with double quotes. But because it's wrapped in single quotes, it will retain the double quotes. Same is true of the password. Now what I'm going to do is I want to create a local Spark table that's going to point to my Azure SQL Database tables. So to make sure I don't have those tables yet, you want to drop them if they exist. So I'm saying drop if exists. Notice it's just a SQL, Spark SQL. It's going to get rid of those two table references. Be careful here because I ran into a lot of confusion where I thought I was recreating these tables, and in fact it was trying to point to old tables. In fact, I deleted the database, and so it was giving me these errors and I couldn't figure out what it was. Because in this statement I said create table if not exists, which means if I already have a reference, it's not going to do anything. It's just going to point back to whatever I had there. So be very careful to make sure you get rid of references and create a new one when you're doing this kind of thing. So now we're back in Python, all right, and we're going to create a little string here, right? It's a, notice the triple quotes. You're not familiar with Python, triple quotes are called doc strings. They're just multi-line strings that retain the formatting you give them, etc. And what we're going to be doing is passing a SQL statement. This is a Spark SQL statement. Again, Spark is the engine underneath Databricks, so although it gives you a lot of value added, Spark is Spark, and this is Spark SQL, so it would work on Spark using, say, a Jupyter notebook, or it should, as long as you have, the drivers and things you need. All right, so what we got here is create table if not exists, using, now this is a really key thing because this is going to get us our driver, Spark SQL JDBC. Then we've got some options here. We need to tell it this is where it gets to the server. DB table is going to get it to our table that we want to connect to, the user and password. And I added login timeout because I'm using a very low-end SQL database and I don't want it to time out trying to connect. And again, I'm using the format, and now I'm passing in the JDBC URL to this. The name of the table is going to go here, right? And then we have our user ID and password. And once we have that string created, we're just going to run it by doing spark.sql run that query. And it comes back and says, okay, I got a data frame created. Now I want to be very careful. What are we doing here? We are creating a Spark table. Spark, local, table, or sales customer. What is it based on? It's pointing to sales LT customer, right? This is the table that is sitting over, go back to my query editor to make sure we're not confused here. Yeah, query editor. Connect in. It's right here. So we're connecting to series LT address, series LT customer. Okay, that's what we're looking at here. So I've created that one. Create it again, just make sure it's good. Okay, and we're going to do this sales address customer. Right, so we're creating local sales address that's going to point to sales LT address. And notice what I said: single quote, double quote. Okay, so that the actual value being passed into the parameter is going to be like that. All right, let me run this. And now, if the gods have blessed us and all works well, I can run this query, standard SQL query. And I left this with the visualization. I can go back to just a tab here. And you can see we've got our table viewed. And now it's just a SQL table. I can run any kind of query, slicing, dicing, joins, whatever I want, you know, julienne your salad with it, whatever. It's all there, so it can do really cool stuff. Can sort, filter, can do all this good stuff. And as I mentioned, you saw when I first came in, you can even do charts and everything now with it. But in the back end, it's communicating with SQL to your backend server, which is a really cool feature. All right, now let's go down here. We're going to do the same thing with address. Did it really work? It did, so we're good. That's pretty cool. But wait, there's more. We can do even more than that. A very common thing I like to do is I like to get data wherever I'm getting it from, and once I get it clean, or I whatever it is I'm trying to do, maybe I've aggregated, maybe I've done certain things, I like to save it locally and then work with it. Because sometimes you're processing, you know, 20 million, 50 million, a billion rows, and you got it down to 50 rows. You don't want to keep running a query to keep regenerating it. So what you can do is, we're going to create a table to hold an extract of data. This is a very just demo-ish, but we're going to be creating something called Spark underscore address extract. Can you guess what we'll be putting in there? That's right. So we'll be creating a table, now that we know it doesn't exist, called Spark address extract. It is a local Spark table, and we're going to be taking data from sales address. So we're actually copying data from the Azure SQL Database down into a Spark table, and notice it's all just in regular SQL because we've already created the reference to sales address. So when I run this, mind you, I could run any kind of queries, filters, functions, all that good stuff. But when I run it now, I now have a table called Spark address extract, and you can see the data. Now, how do I know? Because I wondered this actually. How do I know where it's pointing? Like, is this really local? Maybe it created something in the backend database I don't know about. Well, using the show create table statement will show me what it actually looks like. What did it do behind the scenes? And it did very similar to what we saw before that we ran, except here, notice it says Parquet, not butter. I always want to make that joke. All right, so Parquet. So what's happening with this is it's storing it in a very efficient storage format used by Spark, which is distributed. It stores the data in partitions. It's column store, it's compressed, so it's a really efficient storage. And now we can do all kinds of querying, and we're going to get the advantages of Spark. One of the disadvantages, another good reason for doing this kind of thing, is you don't really want to keep slamming the back end Azure SQL Database with queries all the time, because that's going to get costly on the SQL database. It's also, Azure SQL Database is not designed to handle big data, right? It's good, but if you're slamming away and you really need like billions of rows, you're better off in many cases bringing it down and creating a local SQL table. But again, this technique is a good way to create those references to make it easier for you to bring the data down. All right, and remember, you can do joins and all kinds of stuff in there too, so that's pretty cool. Now, what else can we do? Well, how about creating a database, or a table I should say, in the backend Azure SQL Database? We want to create a table there and do work with it. So let's take a look at how we're going to do this. I'm going to create a table called sales address extract. This table is meant to hold an extract in the database. We're going to write to it from Spark. But before we do this, we need to create this table. It doesn't exist yet. So I'm going to pop over to SQL Server Management Studio. Now I connected to this, just so you know. You can use SQL Server Management Studio, which is a really powerful, does pretty much everything you can think of. It's the best user interface to a database I've probably used in any environment. I even had one we paid for called DB Artisan years ago that I used to use for connecting to Oracle. But SSMS, as it's commonly called, is really powerful. It's got every bell and whistle you can think of. I'm going to connect it this way to it. And this is where I give it the connection string. Same thing as we saw before. It's the server name and then user ID and password. It doesn't support Windows authentication, so you have to give it a user ID and password, which when I created my Azure SQL Database, I gave it an admin user ID and password, so I can use that. So I've already connected here. I'm going to close this for a minute so I can show you. What I want to do is I want to extract data, and I'm going to extract data from sales LT address. So I'm going to create a duplicated table, I'm going to go in here and say right mouse click, script database, create to, new query editor window. Okay. And what I'm going to do is say I want to create sales address extract. And because this ID already exists, I'm going to just put a 2 there. I'll put a 2 here. I'm going to get rid of these alter statements. Now I'm being lazy here because I hate to type create statements in SQL. So I'm going to just duplicate what we already have in this table. Now here's a real big red flag in a database. I had a lot of trouble with these, so pay attention. But identity columns are not something that seems to be supported by the JDBC interface from Spark. At least I couldn't get it to work. What do I mean? I was trying to insert more rows from one table back into the address table with an identity column. And even though theoretically I was setting it, saying the identity insert on so that I could insert into it, it wouldn't let me. It gave me errors. It never really took hold. And I saw a lot of blogs on the internet about that. So if you're trying to do that, just be aware. If you get it working, please post. Let me know you did it and how. But it seems to be a problem. So I'm going to take it out altogether. Identity columns are automatically generated. If you put an identity column, which is very common in SQL Server, it's typically a primary key, integer, and an identity column automatically just keeps adding 1 to the value every time you insert a row. So it's a nice, easy way to get a unique, highly efficient index, clustered index on a table. So it's very common, but it can cause problems because you typically never insert into them or touch them. You let it automatically generate. Meanwhile, back to our story. All right, so we've got a new table we're creating, address extract. Should be all good. Let's see if I can run this and create my new table. Looks like I did. If I refresh my table names, I see I have address extract. Great. Let's go back. And so we've got sales address extract here. Okay, we've got LT here. Let's see if we can make this run. Okay, it looks like it worked. Now, what I want to do is insert into that table, but I'm going to be taking data from this table. Now, I could be inserting from any local tables. That doesn't have to be this. If I could be pulling from just any tables I have sitting around in Spark, could be CSV files. So this is a nice way also to load from CSV files. But what I'm going to be doing instead is I'm going to be inserting into that table, pulling from another database table that I'm already pointing to with the Spark table. That's the table a lot there. All right. So it looks like it worked, and if it did, I'll show you that in a minute, but I also want to show you this. Just to see what did it do, you can see it created it in this create statement that we used earlier. Shows, in fact, it created another table with that reference. And let's query it over here. I can do this in SQL Server Management Studio just to see, did it really write here? And we can see, wow, it did. Which, again, is a very powerful thing because you may have people, perhaps you want to give extracts, summary data, etc. to in a table to finance, accounting, or anyone else that wants data. This is a really easy way to just set up a job that could push data out, truncate the tables, insert new rows, and people can bring it into spreadsheets or do whatever they want with it, which is a nice feature. So it's a very powerful thing. And using these various combinations of just really putting a sort of logical reference, a table which just points to a real SQL database table, gives you a lot of power and flexibility and ease of coding, which is what I'm all about. I like things to be transparent and easy to use, and I think this is a nice feature. What we're doing is we've got an Azure SQL database, we've got a Spark cluster, we've got a table that we're going to create which is referring to a table that's sitting on our Azure SQL database, so that we can just do whatever we want with it. So that's the gist of it. I hope you like that. Please like, share, subscribe. Let people know about my channel, buy my book. It's a lot of stuff. I'm doing more things. Please post comments and let me know what you think of this. Are there more things you'd be interested in seeing related to this? One thing I didn't, for instance, get into is the new service, which is Azure SQL Database Serverless, which is pretty cool. Could take a look at that too. So have a good one. Thank you. Take care.